we're going to be working with your calculators and making sure you understand how to use your calculators to do some of the things we're going to do. So I want to start with this idea about what a degree is. You know how we're looking at triangles and we're able to figure out the angle measures and do something with that. And when we talk about an angle measure, we talk about that angle measure in degrees. So the question is, what is it that a degree is? What is a degree? Yeah.
It's just speaking broadly, it's the level of rotation of the vertices of the two intersecting lines.
Okay, good. In other words, how far has this line been rotated to get up to that one? And the question is, how many degrees make up a circle? 360. So in other words, a degree is 1/360th of a circle, right? Why do you think they chose 360 as the degrees? Any thoughts, Colin?
Because it's a very divisible number.
Yeah, I think so too. It's divisible by 2 and 3 and 4 and 6 and 8 and 9 and 10 and 12, and there's all kinds of them. Though degrees are not the only way we could divide up a circle. In fact, we could divide a circle up into 100 parts instead of 360. Have you ever seen a circle divided up into 100 parts? Like maybe a pie chart? As a percentage, that would be dividing it up into 100 parts. You'll also see if you go into engineering that they do it in 100 parts and they call them gradients instead of degrees. But that's just splitting a circle up in a different number of parts. And then we've got a third one that you'll learn about next year called radians, which is dividing it up into 2 pi parts. And that's a kind of heady concept of how do you divide something by a number that's irrational to start with. But in your calculator, you have the ability to operate in any one of those features, in gradients, degrees, or radians. And what you'll discover is that you can find that by pressing this button, if you're using my red one, that says DRG. And if you press that, it says deg, rad, grad. You have to make sure that your phone is, or your calculator is selected with degrees. If you have it on one of the other ones, you're going to get a different answer. Now, make sure it's set on degrees. And what I want to do is I want to do something that tests your calculator. So I'm going to ask you to think about a 30, 60, 90 triangle. We've been working with these a fair bit, right? So somebody, please, maybe Owen, would you give me a value for this length of side? Any number you want.
12.
12 sounds great. If that's 12, how long is the hypotenuse?
24.
Good. So 30, 60, 90 triangle. So this one is 24. 12 times 2. People remember that? Does that make sense? Now, what if I chose a different size 30, 60, 90 triangle? In other words, a similar triangle, also 30, 60, 90, and I chose this side to be like 3. How long would the hypotenuse be? 6. Do you believe that any 30, 60, 90 triangle would have the opposite side be some number and the hypotenuse be twice that? We've proven this, haven't we? Therefore, this angle, 30 degrees, has a relationship where when we think about the side opposite it and the hypotenuse, that they exist in a ratio of 1 to 2. Agreed? Turns out somebody took the time to build that into your phone or your calculator to be able to tell you guys what that ratio is. I'll start by telling you right now that it's called the sine. And if I do the sine to 30 degrees, what it will do is it'll give me the ratio of these two sides. So it would say, for example, 12 over 24, which reduces to 1/2. Take your calculator, and I want you to do this. Press sine 30 and equals. Okay, did everybody get 0.5?
Yeah.
Anybody get something different? No? Because if I happen to be in radians instead by mistake, my calculator were not in the right mode, and I did sine of 30, I'd get negative 0.988. So this is really important. When we're doing this unit, if your calculator is misset, you will get every single answer on the test wrong, even if you do it correctly. So make sure that you're able to go into DRG, use the arrows to get back into degrees. And the way to check it is that you do sine of 30 is 1/2. Now, a lot of you end up using your cell phones as a means of a calculator when you're at home. So let's go through that process as well. In the event that you're using your phone, of course, sine, cosine, and tangent, and the more complicated functions are not visible on your phone initially. But if you turn it sideways, we get more features, including, you'll see right down here, there's a button that says SIN. Now, it's also confusing because this has the ability to do radians and degrees as well. Notice in the bottom left-hand corner, it says radians. But does that mean it's on radians? Or do I press that? Now it says degrees, but now it says radians up here. It's a little confusing. Turns out you press degrees to get it in degrees. Now it's in that standard mode of degrees. If you want to change it into radians, you press that button. Now you're in radians, and you can press this button to get back to degrees. So we want to do sine of 30 again. Make sure it's 1/2. But if I press sine and then 30, nothing happens. I can press equals. That's not what I want. Sine 30 equal. What is it? It's not working, is it? So that's because different calculators have a different process. Some of them, because they show on the screen what they're doing, like the sine of 30, you enter the function first, followed by the number. For example, if you wanted to do the square root of 50, you could enter the square root button and then hit 50 and then hit enter, and it'll tell you that square root. But if I tried that here, where I tried to do the square root of 50, it wouldn't do anything. Well, it's not supposed to do anything. It's weird. What's supposed to happen is you're supposed to put in 50 and then say, give me the square root of that. So in the same way, if we want to do sine of 30 with your calculator on your phone, you would do 30 and then say, give me the sine of that. Okay, so would you guys please, on both your phone and your calculator, find for me what the sine of 35 degrees is? Everyone getting a number about like that? 0.57357. Okay, good. So that's our first step. So now what we want to do is we want to memorize a particular phrase. This is a really important phrase. And I'll tell you a story about it. Last night, before going to bed, I've been trying to drink more water. I hear that drinking water is good for you. So I drank a nice big glass of water, settled into my comfy bed, and about 3 o'clock in the morning, I woke up and I had to do what? Go to the bathroom, of course. So I get up and I start walking out towards the bathroom. And as I walk past the corner of my bed, it's pitch black, and I moved my foot just a little bit too far to the side, and I kicked my baby toe on the foot of my bed. You ever done that? Yeah. It sucks, right? Like now you got this searing pain in your foot. You don't know if you're supposed to like check and see if your foot's broken or what you're supposed to do. It's the middle of the night. You just want to go back to sleep. So what do you do when that happens? Well, what you should do is put your foot in a hot bath of water with salt in it. In other words, you should soak a toe. Okay, that's a ridiculous story. It's a ridiculous phrase, but this right here, SOHCAHTOA, is the most important thing in today's lesson. You must remember this. No matter how bad my joke is, when you look at me and you go, oh, Mr. Erlin, that joke was so katoa. I'm going to force you to think about this phrase. And the way I'm going to do that is throughout my lesson today, every time I say so, which is like my you guys are going to have to break in, interrupt me, and say katoa. Okay? So, thank you. You got to listen to me. What the SOHCAHTOA does for us is it keeps track of the 3 trigonometric functions that we have in our arsenal right now. The 3 functions are the sine, cosine, and tangent. And of course, they're not written all the way out. This function is actually called sine, but it's only written S-I-N. This function is actually called cosine, but it's only written C-O-S. And this function is called tangent, and it's only written T-A-N. The objective here, the rule about these things is that each one is like a magic wand to an angle. And what it does is it tells you what the ratio of the sides is relative to that angle. So for example, let's say that this is my angle. I'm going to put a little symbol in there that we often use. It's called theta for an angle. And if this is the angle, and I'm asking about the sine of that angle, the magic wand says, okay, I know this angle. If it were in a right triangle, what would be the ratio of the opposite side over the hypotenuse? And the calculator would tell me it's 3/5. If instead I use the cosine button of that angle, it would look into the computer and it would say, wait a minute, cosine's different. The cosine doesn't tell me the opposite over the hypotenuse. The cosine tells me the adjacent over the hypotenuse. So if I plug that into my calculator, I'd get 4/5. And lastly, we've got this tangent feature, which doesn't involve the hypotenuse at all. And it says the tangent of this angle would be the opposite over the adjacent. So the challenge in this is remembering which one goes with which. How is it that I can remember that the sine function is the ratio of the opposite over the hypotenuse? Well, the cosine function is the ratio of the adjacent over the hypotenuse. And the tangent function is equal to the opposite over the adjacent. That's why this information is so, thank you. This is the foundation of it. Okay, so let's take a look at the notes you've got in front of you. And again, this is the most important part right here. So write it here, S-O-H, and spelling matters, C-A-H and T-O-A. I don't love the way this is written, so let's make a little adjustment here. What so means is the sine of an angle. So put a little angle symbol there and then say equals. Do the same for each of these. Because always, always, always after the trig functions comes the angle. And if I take the sine of an angle, what it will give me is a ratio value equal to the opposite over the hypotenuse. The opposite over the hypotenuse relative to that angle. And the cosine will give me the what? The adjacent side over the hypotenuse. And the tangent, because it's OA, will give me the what? Yep, opposite over the adjacent. So for instance, for example, 1 down here, if I'm focused on angle A, there's my eyeball. Would you say relative to angle A, 12, 5, or 13, which one is the hypotenuse? 13, of course it is. Which one is opposite to A? 5. And which one is adjacent? 12. So when I want to do the sine of A, I look at this angle. I say the sine is opposite over hypotenuse. So relative to that A, the opposite side is 5. The hypotenuse is 13. So this value is 5/13. Now we'll do the cosine. The cosine relative to this angle is the adjacent over the hypotenuse, ka. So relative to this angle, I look for the side that's adjacent. And that means the side that's connected to my angle and going to the right angle, not the hypotenuse, even though that's adjacent to. And I would divide that by the hypotenuse, which is 13. And then tangent of angle A, tangent is opposite over adjacent. So what would be the ratio for the tangent of angle A? 5/12. 12ths. Let's try it with angle C. Now we're looking at angle C instead. Does the hypotenuse change? Still 13, isn't it? Does the opposite side change? Yes. Now what's opposite to angle C? And what's adjacent? Good. So when I say the sine of angle C, sine is opposite over hypotenuse. So that'd be 12 over 13. Cosine would be what? Good. Which in this case would be what over what? 5 over 13. And lastly, tangent is opposite over adjacent. So what would be our ratio? Good. 12 over 5. 5. I think I get this. 3. I need to practice a little bit to see. 1. What are you doing up there? This lesson is so. Thank you. Okay, good. All right, please take a moment to try to do numbers 2 and 3. You will notice that number 2 is missing something. What's missing there? You're missing the hypotenuse. You can do Pythagorean theorem to find it. I'm going to give you this one, and then you can do Pythagorean theorem on the third one to find it. Go. So how do we use this stuff, though? That's the real question. So here's the kind of question that you'll typically see. You're going to have an angle that's given to you, and then you're going to have two sides. One side will be a value that's provided to you, and one side will be an x, so a variable that you're trying to solve for. So if I look at this triangle and I put my eyeball where the angle is, relative to that, would you say this x is opposite, adjacent, or hypotenuse? Opposite. And this 19 that it gave us, adjacent or hypotenuse? Good. Now, I can see that I've got two things to play with. I've got an opposite and I've got a hypotenuse. So what I want to do is I want to think about the thing that's most important. I want to think about SOHCAHTOA. Which one has an O and an H in it? So does. Therefore, I'm going to bring in that S, and that tells me that I'm going to use the function that starts with S. I'm going to use the sine function. And always, always, always after the trig function comes the angle, so 28. And that's going to equal a ratio. It's going to equal the ratio described by so. So the opposite side, which in this case is x, over the hypotenuse, which in this case is 19. That's the geometry of the problem. Now we've got a little bit of algebra to solve it. In this case, I've got a whole number equals a fraction. So the easiest way to solve it is to put the whole number over 1 and treat it like a proportion, cross multiply. 1 times x is x. 19 times sine 28 is 19 sine 28. This is the precise answer. I do want you to show this in your work. Please don't skip this and go right to the calculator work, but we can use our calculators now. We can say 19 times sine 28, because I'm using one of these. I can just punch it in like that. 19 times sine 28. Now let me make sure that I'm in the right mode here. I am. I get 0.5 when I do sine of 30. So 19 times sine of 28. 8.919 x is equal to 8.91996, but it wants me to round to the nearest tenth. So what would I call this? I want to kill it there. And the number after here is less than halfway. It's not pushing this 9 up. So I would leave it as 8.9 as my answer. Any questions on that first one? Let's try number 5 together. Part 1, where's the angle? It's down here. Part 2, what do you have? Opposite, adjacent, or hypotenuse? What's the x? Opposite. And the 32? Adjacent, good. Which of our trig functions uses opposite and adjacent? TOA. So I'm going to put in a T. That tells me that I'm going to use the tan function. Always, always, always after the trig function comes the angle. So 41 equals the opposite side, x, over the adjacent, 32. Again, that's the geometry. Now time for some algebra. Cross multiplying. X equals 32 times tangent of 41. 32 times tangent of 41. And I get x equals 27.817. Round its nearest tenths. Cutting it off after the 8. That's low again, so 27.8. Now, is that a reasonable answer? How do we know? Well, we remember that in any triangle, dinosaur idea, the smallest angle faces the smallest side. The biggest angle faces the biggest side, and the mediumest angle faces the mediumest side. We know that the 90 degrees means the hypotenuse will be biggest. So hypotenuse is going to be bigger than even 32 and certainly bigger than x. Is 41 the smallest angle in this triangle or the mediumest? Smallest, because if I subtract 90 from the 180, I'm left with 90. Subtract 41, and I'm left with 49. So this angle, 49 is bigger than 41. That means this side, 32, must be bigger than the side facing 41. 32 is bigger than 27.8. That seems right. I'm in the ballpark. Okay, why don't you try number 6 yourself, please? Yeah.
I'm sorry. You can have it on like the beginning part.
Like these two?
Yeah.
Okay. Did you put your eyeball on the angle? Relative to that eyeball, we're going to look for opposite adjacent hypotenuse. Do you know which side the hypotenuse is every time?
Yeah.
Okay. So the challenge is adjacent and opposite. Adjacent means next to you. So what that means for us is it's the side length that touches or shares the vertex of the angle we're dealing with, and it goes to the right angle. That's adjacent, it's touching us. Opposite is the one way over here. We're not sharing the vertex with either endpoint.
So it's just the two that you don't know.
And we're going to choose the ones, one that's a variable and one that has the number on it that we can use. This is AH. So Ka, it's cosine. Please make sure when you enter this in the calculator, you do it in this order. Put the 26 in front and the cosine of 21 afterwards. Why? Because notice when I punch this into my calculator, it opened a parentheses for me to put in the angle. It said cosine open parentheses 21. And I'm going to get 24.2. But if I did it backwards and I weren't paying attention, notice that I put that 26 in with the angle. And that would give me a very different answer. I don't want that. I could have also done it by closing the parentheses. So X is about 24.27, which would be about 24.3. 5, I got this. This is in my wheelhouse. 3, I think I'm doing okay. I'm going to need some practice and reaffirmation to make sure. 1, I just cleaned out my nails. You should see what's in there. Okay. All right. Let's go to number 8. Set that one up, please. Just do the geometry. Hold before you do the algebra. Okay, everyone got to that part? How's this different? X is in the bottom of the fraction. It doesn't change our steps. We're still going to put this over 1 and cross multiply. But what you'll see is you get a more complicated answer. We're going to get X times sine of 33 equals 15. We can't just jump right to the answer with our calculator. If we're trying to solve for X, right now X is being multiplied by the sine of 33. So how do I clean that up? Yeah, I'm going to divide both sides by sine of 33. So my answer is X equals 15 over the sine of 33. So I'm going to do that in my calculator. 15 divided by sine of 33, 27.54. Yeah, Colin?
Isn't 15 adjacent though? Some opposite?
15 is adjacent to this angle up here, but it told us that we want to deal with this angle here.
Yeah.
Okay, one more problem for us to model. Let's go to number 12. We had a problem kind of like this last night when we were dealing with the special right triangles. Jake leaned a 12-foot ladder against his house. Okay, so here's my house. It's a 2-story house. Always wanted a 2-story house. So here's his ladder. 12-foot ladders. That means this length is 12. And we're going to assume that this house is perpendicular to the ground, as any good house should be. The angle it forms with the base of the house, oh no, the angle between the ladder and the ground is 68 degrees. How far from the base of the house did he place the ladder? So it's asking for this length of X. Part of this problem, of course, is drawing the picture. What does that mean? Once you get the picture, it's easier. I put my eyeball at this angle. This is the angle I care about. Relative to that, am I dealing with opposite, adjacent, or hypotenuse? Adjacent and hypotenuse. That's A and H. So katoa. So the cosine of 68 equals X over 12. And then it looks familiar. Cross multiply. X equals 12 cosine of 68. That's the exact answer, but now I want to get a decimal approximation. Okay, any questions on using trigonometry to find missing side lengths in a triangle? All right, you have the rest of this period to finish this packet. If you have not finished your tests for similarity, and you'd like to work on those, come on up here and we can arrange that.